Morning, everyone. Apologies for starting a few minutes late, but we will get going now. So my name's Holly. I'm the MD of BIMA. Welcome to another BIMA and Microsoft Masterclass. So this is part of an ongoing partnership we have with Microsoft to basically bring their expertise and some of their incredible people to the BIMA membership to give you advice and knowledge. So today we are focusing on language. Before I hand over to Phil to kick off, just wanted to give everyone a very brief kind of roundup of who BIMA are in case you're new. So BIMA is the UK's biggest digital community. We represent digital talent wherever it is. So whether that's agencies of all types and sizes, tech companies, brands, academia, and everything in between. The one thing that really draws us all together is that drive to innovate, to grow business, to be future facing, to bridge that talent gap, to keep your talent, but to really progress within digital and technology. So we cover off lots of different things, whether that's going into secondary schools to talk to 13 to 17-year-olds about the opportunities within digital industry, or thought leadership like this, or the content that comes out of our 21 different councils and think tanks. If you would like to know more, please do just give us a shout. So let me introduce Phil Harvey. Phil is Senior Cloud Solution Architect for Data and AI at Microsoft. He has done many a roundtable and session for BIMA and is going to kick us off now.
Thank you very much, Holly. Yes, I really enjoy having the privilege to work with the BIMA community, whether it's from the agencies or from a human perspective like this. So thank you for the opportunity. Today, we're going to talk about language, and I'm going to break it down into two sections. First section will be an introduction to the overall field of artificial intelligence and language, and something called the meaning barrier that we'll all have to deal with. Then in section 2, we'll talk about analysing language, understanding language, and generating language. And you'll see why I split it out like that throughout the session. So let's get started. When you think about the world of AI, and many of us are, and looking at its applications, it's useful to remember how the different parts of the field tie together. Language started with AI right at the start, when Alan Turing was considering how to judge the intelligence of a machine. Natural language interaction was a key part of that. To compete in what's known as the Turing test, a machine and a human have to have a leveling factor, and this was text communication over a terminal, as we might imagine. You can think about text communication actually all the way back in folklore to the idea of a golem, which was a clay monster, as it was, constructed by slips of paper with what written on it. Very similar to this. Over time, fits between academia and industry and the process has become quite marked. On the academic side, you have the scientific understanding of language works, study of linguistics, to computer science and information. Study human languages with industry, but also notice here natural language generation, or NLG, falls under the broad natural language.
Hey Phil, we've got a sound issue there.
Sound issue on my
Yeah,
side.
you're very quiet.
Hey, that means like I need to get some new headphones.
That is much better.
Is that better? Good. I'm glad everyone can hear me. Thanks, Holly, for letting me know. Okay, let's rattle on. Seems to be technical gremlins day. He's very quiet. Great. So, where were we? On the industrial side, we're talking about natural language generation falling under natural language processing. And you can see here that you have chatbots, which many might have met before, either as a user or somebody looking to build them, all the way through to ideas of search and having people search for what they want in natural language. So this is language as a source of data. So when we start talking about language, we've got to consider this thing called the meaning barrier. And I'm going to start off with something I was advised by many people not to do, which is a philosophy joke. As a philosopher, some people accuse me of being inconsistently clear. I just accuse them of being inconsistently. Pause for everybody having that good belly laugh, because philosophy jokes are definitely the way to go. If we take this point, this is a complex use of language, and philosophers, as strange beasts in the world, often play these language games. This was studied by Ludwig Wittgenstein, and there's a famous quote here that I think is really important. If a lion could speak, we could not understand him. Now, the point is here, a lion is too different from us. The context of the lion's world is completely different. And as language doesn't carry meaning, language only causes meaning in a mind, language only means something to a mind in context, and a lion's context is very different from ours. So if you transpose that to a machine, what is the machine's context in the understanding of language? Another philosopher, John Searle, studied this in this idea of a translation game, where you have language going in, some process converting that language from one to another, and the user receiving the output. Now, in this thought experiment, you can't show in any way that the machine or what's happening inside that closed room has any mind or consciousness or understanding, anything human-like at all. So we find ourselves in a situation of no mind and no meaning. But what we do have in vast quantities is data, huge amounts of data. One of the great sources of language data is Wikipedia at the moment, and you'll see a lot of people talking about that as a core training set. And this is carefully translated language, and it's also highly tagged up because Wikipedia believes in linked data, and there's lots of linking and tagging behind the scenes. What was discovered is that you can take this tagged up language, put it into a magic black box, like the room that Searle described, and to extract some kind of value. What that value is yet to be fully explored, and it's some of the things we'll explore today. Hey, Lydia has joined. Fantastic. I'll keep rolling. We'll introduce Lydia at the Q&A. That's fantastic. Welcome. So everybody started to look for this value and meaning within the data that they had, language data particularly in this case. It's another philosopher, Philippa Foot. She said if you ask a philosopher a question, and after he or she has talked for a bit, you don't understand your question anymore. So when people start to explore data from the perspective of finding this meaning, what happened is instead they found human bias. Data, and language data especially, contains a whole bunch of the bias that's wrapped up in people, what they believe and how they behave in the world. So now we have to work out what to do about that. This is the conclusion of section 1, as it were. So you can see AI and the world of AI has been dealing with language for a long time, and there are many fundamental problems in the way that we use language and the way that language is expressed to a machine that we have to learn to deal with, whether that's bias or whether it's the problem of meaning itself. And what this opens up is a lot of the digital humanities are able to start to explore these challenges and look at the skills of a professional writer and how they convey a particular message, as well as the people who know how to develop these machine learning algorithms. So jumping into section 2, we will see how we can analyze language to start to use it as a data set. And if people have heard me talk before, you all know that I really like this quote from Satya, which is, our goal at Microsoft is to democratize AI to empower every person and every organization on the planet to achieve more. The way that we start to democratize the access to AI is through the Azure Machine Learning and AI platform. There are 5 levels to this, and if you break it down in this way, which is sophisticated pre-trained models, which is where we'll start, popular frameworks such as TensorFlow and things like that, services to help you use these tools more effectively and more powerfully, infrastructure from compute to GPU compute through to FPGA for faster scoring, available on premises, in the cloud, and at the intelligent edge. And as you can see right at the top in the sophisticated pre-trained models, language is a core part of that. You'll see here from vision to speech. Notice how speech and language are kind of separated here. You've got kind of speaker recognition, speech-to-speech translator, and those kind of things, across into the analysis of language, whether that's spell checking with APIs, through to text analysis, translation of that text, through to things like a Q&A maker or the language understanding service. We'll talk about some of these in a bit more detail. Again, if you see me present, I'm only going to touch on this example very briefly, just so I'm not going to go into depth on it this time. But the text analytics service gives you a whole bunch of outputs, extra metadata about your language data that you can use to understand what's happening. So we've got sentiment here, we've got linked entities, named entities. These can include PII or personally identifiable information entities, and these things all can be extracted from the piece of text that you give it. Behind the scenes, this is built on deep learning technology, but what you get to use is an API that means you can start to have access to key phrases, language confidence and sentiment and those things without having to do that training yourself. And as many may know, I've used this to analyze the works of Shakespeare, for example, but I'm not going to dwell on this example today. What I'm going to do is show you a very ugly dashboard that I built in the same way as applying this to the idea of a chatbot being used to help manage properties for a letting agent across the world. And you can see the same waterfall chart of sentiment in the middle. You can also see bottom right, across the different regions where this landlord has property, the volume of comments around different topics and different intents, all the way through to things like a word cloud. If we drill in to Scotland, we can see that the parking issue was resolved, but we only understand this through the chat transcript that happened in that particular place. When you're analysing language, you don't need to jump to the world of deep learning too early. Looking at word clouds, counting words, looking at sentence length, parts of speech, all of these things can help give you a good understanding of what's in the data that you're working with. And this is a key thing. Always you need to consider data science and treating language like any other data set as a key part of your process. You need to know about your data before you try and use the data. Language is no different there. Looking at things like representation in that data is one group of people over a different group of people represented more or less strongly. This is data science work before machine learning, and there are loads of tools out there that are accessible in packages of Python, JavaScript, .NET, anything you like, through to APIs such as the cognitive services that can help you understand these things. So when you're analyzing language, there are other things you can try as well here. One of my favorite ones at the moment that I think is very important because it stretches from data science work and statistics through to deep learning, but the outcomes are very similar. You can look at classifiers, for example. We start off in the top left here, we're looking at a binary classifier. This says, and I trained this in like an hour of writing the code from standing in about 30 lines of JavaScript to say whether a sentence is about a cat or not. And you can see here it's doing a reasonably good job of separating sentences
that are about cats and not about cats. Behind the scenes, it is just a statistical model that says these words tend to mean that the sentence is about cats, like cats and felines and things. You know, sleeps on the sofa is picked up as a cat sentence. That's reasonable, but I am in full control of that process, what the tagged examples are, how the code builds that model, and how I use that to create the classification. It's not a complex machine learning process, it's a kind of statistical model there. The recent tools just allow me to extract from that data much more easily in just a few lines of code the categories and the way of processing the language. More advanced example in multi-class classification at the bottom is how much a particular piece of text relates to a particular genre of film. There's a link to a GitHub repository there that we can share afterwards. And we kind of built this out into a site just for fun because we like building out fun examples. And what I did for this is I put the Wikipedia text about cats to see what kind of film genre it comes out. Turns out cats are funny and a little bit horrific. So, you know, is that accurate? Don't know, but it gives me some scores to start to understand. I can adjust it and I can start to test different things. It gives you a very tight learning loop there. Now, I've come this far with only commenting on deep learning, so I'm going to go into a little more depth here for those people who want to know where the sort of state of the art and where a lot of the research is happening at this point. This is a screen grab of the table of capabilities in the Microsoft NLP recipes repository. As you can see here, under the models, you start to see words like Bert pop up, or glove, word to vec, and these things. These are all descriptions of models and methodologies that come out of academic papers and people looking at things like long and short-term memory algorithms or transformers or these kind of things. And there's a lot of depth in research here, and if I say it in a very gentle way, a lot of PhD time going into this at the moment. But you'll see here you have classification in there. You can do that in deep learning, not deep learning. You can see sentiment analysis at the bottom, which uses different kinds of architectures to do that work. The one I'm going to call out here is summarization, because it shows a really interesting split between generative summarization. So that is where the algorithm is generating a new piece of text to summarize the old piece of text, versus reductive summarization, which takes the text of, let's say, an academic paper and reduces that down, almost boils it down, like reducing a soup, if you will, to create the summarization. The current state of the art there is reductive summarization. And I think that's interesting from a meaning perspective, because you're taking something which a human has produced, which contains meaning, and boiling it down to try and get the essence of that meaning through the algorithm, as opposed to generating something new, which you could consider to need a mind, if you will. Now, this is a huge area of research, and recently this summer we announced our AI supercomputer in collaboration with OpenAI, and we're starting to look at 17 billion parameter language models, which is kind of crazy huge. And there's a lot of investment going in here. The idea is that this will produce a model that can be behind an API for everybody to use, sort of to democratize that process. We can invest so you don't have to, as it were, because what they're finding in the research space is the ability to process and generate language in this way requires that level of compute. And, you know, some people argue that maybe this means we don't need meaning after all. We just need lots and lots of compute. So what's that compute doing? Well, on the one hand, it's turning text into numbers, because a lot of deep learning is essentially mathematical munging of numbers in a sort of try it once and correct it method. That's a very big oversimplification, and there's lots of really advanced things in there. And then the other side of the model is turning the output numbers back into text. Key part of this process is working out how to represent text as numbers in the data set. And there are these extremely clever things called word embeddings, and they're absolutely fascinating as a way of turning text into what's known as a vector space. It's shown here as a kind of three-dimensional chart where man is to woman as king is to queen. And there are papers and things you can look at here. But at the start, we talked about what's in language. And one of the problems in language, as we know, is this idea of bias. Okay, word embeddings also capture bias because they're generating these vectors based on examples that humans have given, probably unknowingly, just in their natural writing. So how does this bias creep in? Well, think about the female to male spectrum of language. On the one hand, we have dictionary definitions. A sister is a female sibling, a brother is a male sibling. These things are built in, the gender specificity is built into the language, their mother and father. On the other side, we have things which are used in common speech that are not related to gender in their core definition. So the one in the center of nurse doctor is becoming quite a famous example, because in Turkish you don't have he or she. You wouldn't say he is a doctor, she is a nurse. You'd say they, essentially, in Turkish. They're a doctor, they're a nurse. But translation algorithms, because they're statistically based on language, translate they are a nurse into English as she is a nurse, because of the statistical usage in the language. This represents that underlying human bias, and there's work being done to subtract that bias out of the way of processing language into these numbers. So you end up with a neutrality where it should be, as opposed to the sort of built-in language gender specificity of sister and brother and those kinds of things. Now, that's on the deep learning side. There's this other side of AI called symbolic AI. And if you look at the state of the art here, there's something called the Mosaic Knowledge Graph, which is under the Allen AI Institute. And this is Paul Allen, the other founder of Microsoft that some people haven't heard of. He invested heavily in other areas that people weren't necessarily paying as much attention to. So this is a knowledge graph, and I put in the word cake, and it's saying that person X bakes person Y a cake, and there were lots of outcomes and links here. So person X is seen as loving, crafty, giving, helpful, all the way through to person, as a result, person X wants to put candles in the cake. This is starting to build up a sort of causal graph. But what we'll see at the top there, bias has crept in here too. Person X wanted to give him a treat. So the target of this cake has been pulled out as being male. But I'm pretty sure men are not the only people who ate cake by any scientific definition. The reason for this is the knowledge graph behind this work is known as ConceptNet, and ConceptNet is a crowdsourced, collected network of concepts in the language space. So that is where that bias starts to creep in. On top of that, they use deep learning to extend the knowledge graph. But that human curation is where the meaning comes from, but also where the bias comes from. And what's interesting in here is ConceptNet has been used to create some word embeddings that everybody can use that perform really well. Where there's a human in the mix to help remove bias and to start to establish where meaning and connections happen, you can get really good results. So when you think about when you're working with data in artificial intelligence for essentially value generation in your business, everybody can help. This is not just a technical task. Having people who understand how language and society and humanity works can help you avoid bias, but also can help you make valuable connections in that data. So language is a key area for that. If we jump now to the concept of understanding language, what is language about? You have API tools such as LUIS, which is the Language Understanding Intelligence Service from Microsoft. This is quite often used in bots, but you can also use the models that are generated that you train yourself through a browser for analysis as well. So what concept of understanding does LUIS use? If you take this sentence, LUIS calls this an utterance, and within that you have something called an intent. In this case, the intent to order a pizza, and you can see how this relates to chatbot technology, for example. The entity they want to order is a pepperoni pizza. Now you can use this for helping to drive action to the right area for chatbots and those automated systems, but you can also start to understand the intents within text and conversation. Jumping very quickly at this point to a sort of bleeding edge example, you can look at the machine comprehension task. So in this case, text on the left being pasted in there. This is about a particular film. You can ask a question. There's a link there. You can try it yourself. I asked who was sad, and it's pulled out the name Imelda Riviera. And in the text, you can see that her husband left her and her daughter, for which, you know, is a reason for some to be sad. So as I've been doing with all these things, I've put in the Wikipedia text about cats because it's an AI conversation and that's usually about cats. So I asked, does a cat have slow reflexes? And it's pulled out this piece of text about reflexes, which is a useful answer. What was initiated in ancient Egypt? Cat domestication. Okay, great, a useful derivation from that text. Then I asked it, what is my cat called? It says Felis catus. But more for you, AI, I don't have a cat. So, didn't get that one right. Context still matters to some extent. Yes, that was a joke on my behalf. It's very clever, and you can read more at the bottom. Now here, what you can see is I talked in the summarization example about reductive summaries. The right-hand side, where it says this is my answer, is a reductive summary. The other side I talked about was generative, which is generating language from other language. And that's what we're going to talk about in the next section. Putting myself out here a little bit, I've given you my favorite philosophy joke. I'm now giving you my favorite poem I've managed to generate using artificial intelligence. So I fed it the picture at the top into a vision algorithm that pulled out the description, a bird sitting on a branch. And now we have this rather scary poem. You know, I'm not going to read it to you because I'm not going to do poetry on a Tuesday morning to people, but there's a collection of text here, which if you read some of the lines, there's some quite beautiful passages in there. If you were presented this as a historic poem, maybe you wouldn't see too much difference. One of the things it doesn't have is any understanding of grammar whatsoever, because I wrote it and I have pretty much a poor understanding of grammar anyway. What I did is I took some famous blocks of text, you can see Shakespeare in there and also Edgar Allan Poe, and I built a model. This model is incredibly simple. It's a model of when you have a word, which word is likely to follow it. This is not using deep learning, but it does use a similar concept of the space around a word and what is meant because of the relationship with those words. Then I have another piece of code that triggers that model. As I said, I took the computer vision output from the picture and sent it some of those tags 5 or 10 or 20 times, tagged it for sentiment because that's easy to do, and then generated that poem. So maybe if I decide to put some time in learning about grammar, I'll be able to make that better, but also templating is a good thing here to work out, you know, common phrases and things like that to help guide how that poem is constructed. Again, jumping from the really simple example I can put together myself through to a deep learning example, we have Pixter Story, link at the bottom, from Microsoft Research. So a picture on the left, and I've chosen a thriller here. And if you're of a delicate constitution, you might find this rather horrific, but it generated this story. Disturbance car was parked to the side of the highway. He shook his head in disbelief and said, "Can we get out of here?" Corey cursed himself for not being able to inflict any more pain on the wound. Bit of a strange thriller story to kick off. Grammatically, slightly better, a few more capitalizations and full stops, but not particularly meaningful. You can see the holes in that. If we jump from this to one of the models that just before this week was considered state of the art, GPT-3 has come out recently. We'll take GPT-2 and the playground in this example. Again, we've used the text about cats from Wikipedia, and it decided to generate the sentence marked in blue. So Wikipedia is secretes and perceives pheromones, being about a cat. GPT-2 thinks it regenerates about 2 to 3 hours after its dormancy. End of text, Salt Lake City, Utah. Bit strange, grammatically correct, maybe, poor use of spaces, but actually not particularly magical. Now what you find here is in the research space, which is getting a lot of investment and attention, there are some specific examples, often around the text resource of scientific papers, where these kind of algorithms are performing very well. There's a good alignment here with the problem of vision algorithms that are using the common test set and things like that to train on, so ImageNet and those kind of things. And we find that this problem of meaning kind of lives within the field. You start to see it pop out because we're so used to reading language that we can spot it as people very easily when something's not right because the meaning is just not there. So to conclude, giving you a whistle-stop tour of where we kind of are in the state of the art, from what you can do yourself to analyze language, through to the tools that help you understand language in some form, all the way through to what you might use to generate language, whether you've got a large amount to invest or a small amount to invest in a laptop in an afternoon. So huge advances recently, and you'll see things like the AI supercomputer, and we're very proud of the work that we're doing there because we're really pushing the state of the art. There are active areas of research, and what this means for you is there'll be outputs from the research you could use if you don't want to invest in that research yourself, all the way through to the idea that actually people are still working on this. There are some algorithms which are really good, and you can use them kind of now to get some great results, like a bit of regression and those things. But actually, language is an active area of research, and it has been for maybe 70 years now. The quickest route to value for you is to get new, useful metadata with language analysis. So look at the sentiment, look at the parts of speech, look at the different groups and representation in the language to learn something as if you were looking at any other sales data. Like, where did people buy that pair of shoes? Where did people say these kinds of things? Is a valid analysis and very straightforward to do now. Use things like the cognitive services first and those sort of pre-built models that give you that better metadata. Microsoft is working very hard to reduce the bias, whether it's from the language embeddings or anything else, as much as we can. And you get the advantages of that research through the cognitive services. And then when you find the value engine in it, then you can start to do something more advanced. So thank you very much for your time. I see we've got some questions coming in, but first of all, I wanted to introduce Lydia Gregory, who has joined us now. Say hello to everybody, Lydia.
Hi, thank you so much, Phil. Thank you for the really great presentation. Apologies for being late. As ever, the simple bit of technology of being able to sign in that tripped me up. But thanks for having me. Just to introduce myself, I'm Lydia Gregory, been a member of BIMA for a number of years, and I'm CEO of Founder Feed Forward, and we work on AI in the creative industries. And specifically, our use case with language is we have built a music search engine, which is all about understanding the meaning of words in the context of music. So actually, when one person's using a word such as chilled, what do they mean in terms of music? Which audio are they looking for? And the same as genre. So it's super interesting hearing what you're talking about, because I think, yeah, for us, we have to be so careful about getting the meaning of words right in the context of music, and then looking at it within the context of each user in music. So yeah, it's brilliant what Microsoft is doing. Where should we start? Should we jump right in with questions, Phil? Yeah, perfect. So there's a couple here that have come in, and please do keep them coming in on new, and we can keep asking them. So there's a couple here that have come in from WH, and I think a really pertinent one: how do we find the right resource to come and make AI for us? And I think this one's interesting because, as you've pointed out, Phil, actually you can start off by using services from Microsoft, and perhaps you're saying actually this makes it accessible to people who are developers but might not be specialists in machine learning. Is that right?
I'm off mute. Great. Yes, that's exactly right, Lydia. The first place to start is what developers do you have now, who do you have access to, and what tools are right for them. There is value to be got now if you haven't analysed any of the language you have accessible to you. If those developers and those skills aren't within your business, Microsoft has an extensive partner network, and BIMA as well represents a great network of companies who will be able to discuss that resource with you. I think WH asked a follow-up question there, which is where can we get the right binary from, and where do we start? That's a really interesting question, because it speaks to the heart of this democratization. A lot of the traditional pieces of software that you might have downloaded as a library or a binary before are available via API. So they're made available on a cost per call basis. And depending on the volumes of language, that can be a very cost-effective way to start. You then can start to look at how to download the models and where they come from. In Microsoft's case, we make them available as containers in some cases, so they fit into your containerized language landscape of microservices. So there are many different ways, and it depends where you kind of want to start. ML.NET is a great extension for the .NET language. There's one called NLTK as part of the Python language, which you can search for in the package manager. And Natural in JavaScript is also a really nice library. It's one that I use personally because it's very straightforward.
That's really good advice. And I think lots of people in the BIMA community will have tech teams. And I think we certainly find our team is a blend of people who come from a software development background, but then are interested in machine learning and actually have to know how to deploy the models, so have come from that direction. And then we have the mathematicians and the people actually defining the algorithms. And there's this real sweet spot of getting them to work together. And I think you tend to find people who are already software developers and really good at what they do will have an interest in actually extending those skills into machine learning. And one thing we actually find as well is you've got to, if you're working with your own machine learning models, actually skilling up your software engineers to be able to deploy those models. There's a whole kind of architecture that goes around the machine learning process that's important as well. That's really good advice. I think there's another interesting one here from Abhishek saying, so you just checked out pics to story. Are there any plans to allow you to upload a pic from your own gallery and tell a story based upon that?
I think that's a fantastic question. At this point, as I understand it, no. The reason for this is that the general public are keen on uploading many different kinds of pictures that may or may not produce a story that is palatable or is particularly good in a screen grab that is then posted on social media. So in those kind of live sites, they're very guarded about it. I can tell you now that using probably, let's say, 2 screens of Python, I could use APIs to generate something similar. But in that particular case, no, there aren't any plans to allow you to upload your own picture at the moment for the reasons given.
Very interesting. That sounds fair enough. I've actually got a question for you myself, if that's okay. It's partly about the bias. Let's start with bias, because I think it is a really important point with language. Like at the end of the day, anything machine learning based is learning from words that have been generated by the human population at some point. And one thing I noticed, actually, the example you gave of the Turkish obir hemseri, I probably said that really wrong. I've actually noticed, so that observation originally came from a paper that came out in 2017, just pointing out this bias that existed. And subsequently, the Google Translate interface has now changed, and they actually give both gender translations. And so they come up with an interface solution to something that is still a machine learning problem. And I thought that's really nice and kind of ties into the fact that actually you need a really multidisciplinary approach to building this software and having the right intended effects. I was going to say though, because like with the capabilities you've got, Microsoft, clearly there are data sets that your models have been trained upon that actually the users of them don't have access to. And I wanted to ask, like, if people in this community are using Microsoft services to build whatever experience it is, perhaps it's something to do with marketing, and they come across either meanings of words that come up that perhaps aren't relevant for what they're doing, or there's something that has got some bias in it. How should they tackle that? And is there a way where they can actually kind of dig in via your platform, or what approach should they take?
Sorry, everybody, I'm having trouble with the mute button. I should be there now. So I think what you'll find is on the pre-built model side, and this applies to vision and language and everything, the outputs, whether it's sentiment is the most difficult one because there's lots of slang and different usage around the world for different meanings. But if you look at things like named entity, it's still in preview because we're exploring whether, in the example I gave in the sonnet, they talk about sap, which is from a flower and has lots of metaphoric meaning in these things, but it was tagged as a company because SAP is a company in the world. And behind the scenes, this is using the Bing knowledge graph, which is something you can explore to start to extrapolate those things. In the same way as with vision and any other model, if the pre-built model, which is for the general case, is not suitable for your use, you need to start to look at the next stage beyond that. And the techniques where you're able to tag and do a piece of supervised learning where you can train the model yourself. And you're looking for things like transfer learning first, where somebody produces a model that you then tailor to your own needs. This is where the learning curve, just as you described with your own team, as people ramp up in skills, people have to learn a new set of things. And you'll find that you're suddenly exposed to a huge amount more bias than you were with a pre-built model, which somebody else has done that work already. And so there are these sort of learning gradients, which your team will have to go through. And this is where you focus on whether you're building it or you're going to partner with somebody else who's already gone through that journey and has those skills and are able to use their team as opposed to yours. Because, as I said, language is a really active area of research, and the tools for detecting and managing that bias and where those land in the system. And I think you made a great point about how to operationalize these models and then test what they're doing as they're out in the wider world, and that data is really important. So hopefully that gives a kind of answer, if you will.
Yeah, well, I think I think the word bias as well, it's not just bias, it's context, isn't it? Because so yeah, with what we're doing with Figaro and language and music, we find the use of words in reference to music is very specific to the music context. So for our use case, we can't use off-the-shelf models because we're basically trying to learn which elements of the music give a word a meaning in the context of music. And you even find across languages, the word funk will have one musical meaning in English and it'll have another meaning in another language. So there's a lot of kind of very domain specific meaning in what we're doing. So we kind of have to really start from the data and start from scratch. And you mentioned a lot with the models that you're working with, like you've got this huge corpus of data from Bing, and it is quite general. I guess are the outputs that you get from Microsoft services, are they very general, or do you find that they are specifically suited to certain use cases? And I know you've mentioned like marketing and maybe kind of sentiment analysis of Twitter feedback or something on a product. Like, do you find there are certain areas that it works really well for? And I don't know if you've got any kind of use cases out in the wild, and maybe other more domain specific areas where people might need to be considering building in-house.
Yeah, so I think from a Microsoft perspective, we're especially in the partner space where I work, we're very focused on sort of enterprise language. So we have tools that are very good at picking up company names as opposed to botanical elements and things in there. And one of our partners, who's part of the community, works in the regulated industries and has seen great success with our technology. And they've spoken about it on many forums. I won't name them now in case they're not on the call to represent themselves. But when you have that tight domain around enterprise and specific utilities or regulated industries, it performs very well. And I was doing a piece of work myself when we were looking at the financial services sector. The sort of named entity recognition there is fantastic because there are lots of companies, there's lots of data out there in the search space, the kind of stuff that you would index. As soon as you come out into a specialist area, and I think your music example is fantastic, that's where you're going to need to check. And this is what I'll say very specifically, always test. Nothing is going to be right first time. This is an area where you need to explore the application to your business, and you need that diverse team and diverse attention on it because there are so many things that you can miss in the use of language, which can be both everything from the spectrum of abusive and you didn't know through to something highly complementary that you completely missed, and you're missing an entire market because you're not able to explore that internally.
Yeah.
So that's where the boundary is, that anything you're going to use, you're going to test.
Yeah.
And as soon as you find that edge, that's where you're looking for the area to build yourself. Yeah,
that's really, really good advice. Well, I think there's another actually question come in. Abhishek's got some interesting questions about is it possible to use the same image text analytics on real-time videos? For example, with the Premier League coming back soon, could we run the analysis continuously and create a commentary? There's also the idea of spotting the highlights. And I think just reading this question, I think my initial response is, I think the key point is actually working out why, like what your use case is, why you're actually doing, what the end purpose of doing this analysis is. Because from my perspective, I'd look at the sports use case, and I think probably creating a commentary, that's really hard. Like actually generating a meaningful commentary, again, like the type of what you're expecting from a sports commentator is quite specific. But you're probably going to get it. We know that the technology is good at spotting highlights. I hate to mention a competitor, but there is, I think it was IBM who, with Wimbledon last year or the year before, I lose track of time, did exactly that. They basically edited the highlights videos of Wimbledon using AI. But what's interesting is they weren't actually analysing the image in that context. They used the crowd sounds, because they found that as a more reliable way to gauge the kind of the energy of a game. And I think that's a really interesting point about kind of, you know, if you're considering any particular context, actually when you're looking at what data you have, think about actually what kind of break it down. So yeah, if you've got video, you have both images and you have audio, and actually working out which one is giving you the meaning that you're looking for. I don't know that his question is this latter part is most interesting. Are there any pre-built libraries for generating fake sounds? I'm intrigued. I wonder if Abhishek could provide a bit more context, because I see three use cases coming up here. There's the creating of commentary, and my take on the commentary is probably possible to get just kind of statements of what's happening, but it'll be harder to get that kind of human flow of commentary, because that's much harder. It is possible to have to identify highlights. I'm not quite sure what is meant by generating fake sounds. Is that for gaming the system?
So if giving Abhishek a chance to type in there, in terms of Microsoft tools, if you're looking at the video indexer, would be a good place to start. So it's if you go to vi.microsoft.com, is a good tool to explore what we've pulled together into a video analysis and video indexing system there, which can help with each of the pieces you're talking about. I think the just while we're waiting on the context there, the generation of sound, I think, is the neural text to speech area is really interesting. So trying to generate realistic sounding speech, and you think of audio books through to voice bots through to other pieces there. Now, I've not seen anything around crowd noise itself, but the techniques of taking recordings of sounds related to video clips and points in a game, for example, and then training a model based on that. The methodology is there, but I've not seen anything on the generation of crowd noise itself. But I think that's a really interesting example.
I mean, my take on anything generative for businesses out there is, I think generating anything, whether it's images, video, prose, that is realistic to a human consumer is difficult, right? That tends to be the kind of most difficult end of anything AI, any AI applications. And you've got very specialized research and certain specialized companies really focusing on that. My take is that if you are a business who perhaps is a digital business, but is not your core, you know, you're not waking up every day and just focusing on AI, actually you're more likely to find value in some of these use cases that are more about identifying or classifying some data that you've got. So in this sports example, identifying, is this moment important enough? Is it a highlight? And then does that help me to edit my video? Is probably a more realistic point to find value than thinking, can I generate a human realistic commentary? So I think this is where, for me, it always comes back to, like, what you know, what's the end goal? Who are you selling your output to, I guess.
I think that's a fantastic point, but I did want to, as you work in the music space, I did want to ask you one thing.
Yeah.
Have you heard the continuously generated, artificial intelligence generated Scandinavian metal music that's available online? Because I think some of that is remarkably good.
Yeah, I haven't heard that, but I've heard there's a new one that's come out from OpenAI, where you give it actually you could generate some stuff from Microsoft, and you basically you feed it a genre, so folk or something, and then you feed it some lyrics, and then it will literally generate the sound, generate a song around those lyrics. But I think this is where the kind of what's the system generating and what data is it working upon, interesting, because it is literally generating the sounds, as opposed to kind of, you know, putting together bits of production. And some of it's really quite interesting. Like, it's not perfect, it's definitely got what we call artifacts in there, but it's pretty cool. I think you tend to find what's interesting, I think, about that is by giving it lyrics, you're actually giving some kind of structure to the output. And I think one of the problems that's been seen in previous kind of generation of anything, music related, is actually getting it to make sense over a long period of time. So without wanting to be rude to kind of Scandinavian metal, perhaps one of the reasons it is so convincing is it is kind of similar in sound for a long period of time. But if you try and generate other types of music which have kind of, like, I don't know, some kind of like classical or a pop song which have structure, getting both stuff that getting a system to output something that makes sense locally, you know, over a short period of time, and makes sense over 3 minutes, 4 minutes, that's what becomes really hard for these models.
And I think that's a really good analogy to bring us back to language. I've just noticed at the time here, where the same thing for a flow of a piece of prose.
Yeah.
Right. So a piece of music, a piece of prose, there's a strong analogy there that generating something based on a few words to turn it into a few paragraphs or whichever, or a few bits of data, it's still hard.
Absolutely. Cool. Well, I think, shall we pass back to Holly and the BIMA team?
Thanks, Lydia. Thanks, Phil. I could listen to you all day, and I know very little about it. I foresee a BIMA Microsoft drop-in clinic on AI in future. So we will be sending a follow-up email to everyone with all of the links, etc. This will be available on YouTube, but also you can just use this Microsoft Teams link at any time and go and view this session again. So please do, you know, share it and do, you know, use it as much as you can. What else? So we also have a few places to a Microsoft hackathon. So it's a 3-day online Teams hackathon in, I think, about the middle of July. So if you've got projects that you want support on, or ideas that you want to build, please, we'll also send you the link to that, so you can submit where you're at with the project, etc., on our website, and then we will pass it on to Microsoft and they'll be in touch. But my understanding is that it's an incredible opportunity to have lots of very smart people help support you and speed through some stuff. We have a mental week this week, so tomorrow morning we're just doing what's next in public health, because, you know, why not? So should be really interesting, covering off social messaging that's happened, track and tracing apps, and the role of technology going forwards. So I'm sure AI will be talked about quite a bit in that. And then on Thursday afternoon, we are talking about data and CDPs with Acquia and our Data Council. So please do sign up. Thank you so much to you both. Have a brilliant rest of the day, and we'll see you all soon. Thanks.